Guys, the third type is the rose curve, which we refer to as flowers. The form that they look like is this: r equals a cosine of quantity n theta, and r equals a sine of quantity n theta. I always tell people if they, really want to impress someone, they could make one of these on their graphing calculator and hand them a flower. I know. Math teachers. Okay, so how do you figure out what these look like? Well, if n is odd, here's your n, you're going to have n petals. That works for both the cosine and sine. If n is even, you have 2n petals. Again, for cosine and sine, that holds. Quick little examples up here before we go through other things in a full-blown example. Don't mind my scrap paper, as you saw I had in class. So, if, again, we're looking at the cosine, come on, man, a equals cosine of any time, n theta. So if n was 3, you have 3 petals. A is the width of that petal. Let's see by just looking at these if you can come up and figure out where the cosine petals will start and where the sine petals will start. Maybe between the two cosine examples you can figure that out. Another cosine example, if n is 4, notice you have 1, 2, 3, 4, 5, 6, 7, 8, so that's your 2n petals. A is the width of the petal. Again, these are all supposed to be drawn the same width, but obviously they're not. Again, notice where your cosines, where they start. Hint, hint, we'll talk about that in a minute. I'm not really giving you much hints for the sine. If it was a sine, and this was n equals 5, you have 5 petals. Notice it's not starting at the same place. And A, again, is the width of your petal. All right, so what does that all mean that we just looked at? So where do the petals go? How do you actually graph these sort of equations? So if it was a sine one, there are 2 little expressions you can use to help yourself. You take 180 degrees and divide by 2n. That tells you your first petal position. So notice this one up here, our first petal position is right here. Again, that was just a sketch. And then also, if you take 360 and you divide by how many petals you have, that tells you the number of degrees between each petal, which is going to help us when we need to make the chart. These charts are going to look different than the ones we just did, because you won't always necessarily be doing 0, pi over 2, pi, etc. For cosine, did you guess? The first petal is always at 0 degrees. I know you're like, well, lady, you only showed us 2 examples, but yes, that's right. If you were thinking that, you were right. And 360 degrees divided by the number of petals, that also tells you the number of degrees between petals. So these are little notes to help you graph them. The example I'm going to do is a cosine one. So we have r equals 3 cosine of 2 theta. So things I need to figure out is, well, first of all, how many petals do I have? Well, n in this case is 2. 2 is even. So that means I'm going to have 4 petals, because 2 times 2 is 4. Other things I want to figure out, since this is cosine, well, I know I'm starting at 0, but I want to figure out how many degrees between each petal. So I'm going to take 360, here we go again, and divide by the number of petals. Come on, so how many petals did I have? I had 4. And so 360 divided by 4, that's 90 degrees between, I'm just going to write that for myself, in case people look at these notes later. They know what that means. So you might be like, well, you just told us this table isn't going to look like the others. Well, this one is, but it's not always going to be, like I said, 0, pi over 2, pi, 3 pi over 2, and 2 pi. It depends on where your first petal is and then what you are increasing by each time. So for this example, it's cosine, so you're going to start at 0 degrees, or 0 radians. I'll do degrees, whatever, to be different. Okay. And then I know that I have 90 degrees between petals, so I'm going to add 90. So 90 degrees, add another 90, 180, add another 90, 270, add another 90, 360, and I'm done with my full rotation. So now I'm just putting these into the equation. So cosine of 2 times 0, that's the cosine of 0 degrees, times 3, that's going to be 3. 90 degrees, that's going to be negative 3. 180 is going to be 3. 270 is going to be negative 3, and 360 is going to be 3. Yes. Yay, you noticed the pattern. All right, so here we go. So 0 degrees is at 3. So here's my dot. Okay. Next, we have 90 degrees is at negative 3. So here you are at 90, but you need to flip down to negative 3. Okay, so for the sake of understanding this, I am going to draw this in as I go. And I'm going to put arrows on. This is not something you need to do as part of your graph. It's Paw Patrol time, guys. Can't hear. Don't need the arrows. I just want you to realize how this is being drawn. Okay. My next one is at 180 degrees 3. Okay, so here I am over here. So remember, I was just right here. I'm going to come over here. Again, just to show you how this is being drawn, the arrow, it's going like that. Your next one is at 270 negative 3. So 270 would bring me down here, but I'm at negative 3. So that means I have to go up here. So I'm going to come around like this. Okay. And then your last one was at 360, which you're already there. But you're coming around like this to end. Again, these arrows are not part of the graph. They're just for demonstration's sake. If you're like, well, Mrs. Swanson, you never actually crossed the origin there. Well, I can show you what the 0 would be. Okay, so to find the 0, you'd have 0 equals 3 cosine of 2 theta. You divide by 3. 0 equals cosine of 2 theta. So we're taking the cosine inverse of both sides. We have pi over 2 equals 2 theta. See how all this is coming? Oh God, was that blurry the whole time? Where this is all coming into play now. So theta is pi over 4. So I mean, technically, that's the point. Your r is 0, pi over 4. So it is part of the graph. It's just not part of the table. And there is your rose. How pretty.